Classwork 8, solve inequalities. So let's see the first one. The first one, we see denominators. Right? We see we have here we have 1/6. Here we have 1/12. So we're looking for the least common denominator. The least common denominator or least common multiple. We could think two ways. We could think least common multiple, or we think 6 and 12. We're not thinking about a common factor. Okay, a lot of times we're thinking about the common factor. Here we're thinking about multiple. So that would be a 12. Because multiple is a bigger number. Even it says the least, but it's a bigger number. So what do? So we want to multiply by 12 on both sides. Multiply 12 on this side. Multiply 12 on this side. Multiply 12 with this term. Multiply 12 with those two terms. Right, then 12 times this one. So we could think of 12 divided by 6. That's just 2. So 2 times the numerator. Numerator is 4x minus 3. And greater than or equal to, then 2x minus 1 divided by 12 times 12. Remember the 12 in the denominator is 1/12. So 12 times 1/12 becomes 1. So we just have 2x minus 1. Then we have -2. -2 times 12, that's -24. So you see the beauty of this? After we multiply by the least common denominator of 12, we don't have denominators anymore. So let's simplify this. 2 times 4x, that's 8x. Minus 2 times -3, that's -6. Greater than or equal to 2x minus 1 minus 24, that's -25. Now we want to combine like terms. So before combining like terms, because the like terms are on both sides, so we would move 2x to this side. When we move, it becomes negative. Simultaneously, we can move -6 to this side, it becomes positive. So after moving, we have 8x minus 2x greater than or equal to -25 plus 6. All right, 8x minus 2x, that's 6x, greater than or equal to, well, -25 plus 6, we can think as negative of 25, parenthesis, minus 6. 25 minus 6, that's 19. So we get a -19. Now we divide by 6. So solution is a fraction. So x greater than or equal to -19 divided by 6. Well, 19 is a prime number, so it cannot be simplified. That's it. So the solution is this. So how do we graph on a line? So first we graph this line. We indicate it with an arrow to see this is a real number line, right? Let's see, 0 is somewhere. We can mark 0 anywhere for our convenience. Now we just mark -19 19/6. We only have to mark those two numbers for this question. Sometimes we may need to mark more numbers. But for this question, we only have to mark our 0. Always mark the origin first. Because towards the right-hand side of 0 is positive, towards the left-hand side negative. Then we mark -16, 19/6. And that's it. Let's see second. Second one, we see, let's look at A. A, we have one expression sits in the middle. We have one on the left-hand side. We have one on the right-hand side. So we have 3 sides. So we can subtract 3 on 3 sides simultaneously. So -9 subtract 3 less than or equal to 3x plus 3 minus 3 less than 21 minus 3. So it's like an equation. You know, I have those 3 sides. I can do something simultaneously, but something have to be the same. Now I simplify. So -9 minus 3, that's -12. Less than or equal to 3x. Because the positive 3 minus 3 becomes 0, right? That's my goal. That's exactly why I subtract 3, because I want to get rid of this 3 in the middle. Then I want to get rid of the 3 multiplied by x, right? Dividing by 3, that's the next step. 21 minus 3, that's positive 18. Now I divide by 3 on 3 sides, right? Negative 12 divided by 3, get negative 4. 3x divided by 3, that's just 1x. I don't bother to write 1 in front of x, so just x. 18 divided by 3, that's 6. So that's my solution. So x is in between negative 4. X is greater than or equal to negative 4, but less than 6. So how do I graph it? Right. Graph my real number line with an arrow. Okay. Put 0 somewhere. 0 here. Now I need a negative 4. Maybe negative 4. Let's see here. Then this would be negative 2. So this is my negative 4. I need to mark 3 numbers. I need to mark my origin. I need to mark negative 4. I need to mark 6. So this is about 2. This is about 4. So 6 is somewhere here. And then my x value sits in between of those two. I'm including negative 4, which are marked, because of the equal signs there, I mark a solid dot, filled circle. I'm not including 6, so I make an open circle. So my solution is in between of those two. I just mark like this. So that's my solution, right? So x value in between of negative 4 to 6, including negative 4, but not including 6. So this is AND, or next one, B is OR, right? So let's solve each one. Let's solve for the first one. So I have the minus x on both sides. So 5x minus x, I will get 4x less than or equal to 1 plus 3, 4, right? So I moved x to the left-hand side. Simultaneously, I moved negative 3 to the right-hand side. Now I divide by 4. So x is less than or equal to 1. So that's the first inequality. For the second inequality, I want to divide by negative 4. When I divide by negative numbers, I switch the sign. I switch the sign. Less than or equal to becomes greater than or equal to now. So negative 4, negative 8 divided by negative 4, that's 2. So I have these two solutions. Well, let's graph. But I'm looking for or, not the AND. So I put an arrow here. I make a 0 somewhere. So my origin is somewhere. I need a number 1. 1 maybe here. I need a number 2. 2 maybe somewhere here. So my solution x less than or equal to 1 for the first one. Less than or equal to, right? Solid dot, because equal sign is there. Solid. Less than, I go to the left. I go to the left. Well, second one is x greater than or equal to 2. Also with the equal sign, I make a solid dot. Greater than, I go to the right. Right. If this will end, then there will be no solution because no overlapping. But this is an or. So how do I do it? I want to write in interval notation. Right. So I write this way. I write negative infinity up to 1, including 1, union from 2, including 2, up to positive infinity. So that's my solution. Right, from on the very left-hand side, negative infinity is waiting. Right, so how do I write this interval? I write from negative infinity up to 1. On the right-hand side, positive infinity is waiting. So I write from 2 up to infinity. Right, that's for those two. Now let's go to 3 absolute value equations. Absolute value of 2x minus 1, absolute value of negative 3 plus x. So the two cases. The first case is both of them are positive. So if both are positive, it's just equals to themselves, right? So both positive. So this case is, let me notation, both being positive. So first case, then we just solve. Okay, solving part should be easy. So we get 5x, we move negative 3x to the left-hand side equals to 5, which x equals to 1. First case. Second case, they're opposite, which means one is positive, one is negative. So we can write as 2x minus 1 equals to negative of negative 3x plus 4. So this means they're both opposite. Opposite means one is positive, one is negative. Opposite. Yeah, opposite. Okay. The opposite. So we can just put a negation sign in front of either one. You can put in the first one, or you can put in the second one. So now we have 2x minus 1 equals to negative 3x becomes positive 3x, negative 4 becomes negative 4. Then we subtract 2x on both sides. We get x. Well, then add 4 on both sides. So we get 3 equals to x. So two solutions to satisfy this absolute value function, absolute value equations. One satisfies it, and 3 satisfies it. So number 4. So this is the absolute value inequality. So we focus on this sign, less than, right? Less than. So let me graph the line for you. Less than set 11. Okay, let's see, 0 is here in the middle. Absolute value less than 11. Let's think about this, positive 11, then somewhere negative 11, right? Then when we absolute value of negative 11, that's positive 11. So absolute value means we only consider the distance from the origin. So we say here, so here, right? So the solutions has to be in between of this. And that's negative 3x plus 7. So the value of negative 3x plus 7 has to be in between those two for the absolute value to be less than 11. So what does this mean? This means negative 3x plus 7 is less than 11, but greater than negative 11. Oops. Greater than negative 11. That means this. So we just solve. We subtract 7 on 3 sides. So negative 11, subtract 7, that's negative 18, less than negative 3x. Now less than 11, subtract 7, that's positive 4. Now we want to divide by 3. When we divide by 3, well, negative 16, negative 18 divided by 3, that's negative 6, less than, oh, now we have to switch the sign because we're dividing by a negative number. We're dividing by a negative number. We're dividing by a negative number. So what do we do? Let's split it into 2. So one way you have negative 3x greater than negative 18, right? When we solve this one, we get x less than positive 6 because we're dividing by negative number, right? Another way, we have negative 3x less than 4. When we divide by negative 3, we get x greater than negative 4 over 3. If you want, you can do simultaneously, but switch the sign, okay? Let's switch the sign. So now our x value is, let's regraph this, right? Regraph this. So x is less than 6, but greater than -4/3. So only need the number 6. Let's change this number to be 6. And -4/3 is -1 and 1/3, right? Somewhere here. So just mark -4/3. And our solution is in between those two numbers, but not including those two numbers. We make an open circle. We draw a line in between of those two. And that's it.